different engagement here with the new group of people.
This meeting is being recorded.
Let's see, I'm gonna try to, usually don't use Zoom, so I'm gonna, there's the screen share, okay. All right. Give me 1 second, sharing. I think I'm sharing it now, if everybody sees that.
Looks good, Aaron.
Slide. Okay. All right. Well, I appreciate folks being here and listening in. I kind of gave a little bit of background information. I wasn't quite sure kind of the bandwidth of knowledge in this group. So this is very, very casual. And if there's any kind of questions along the way or whatever, just feel free to interrupt me. We can kind of have some more as a casual conversation more than a really formal presentation or anything. But so TEMPO, if you don't know, it's a Tropospheric Emissions Monitoring of Pollution mission. We had really great updates recently in terms of being integrated with Intelsat 40E, which is our host geostationary satellite. TEMPO will be the first ever spaceborne spectrometer instrument to in geostationary Earth orbit to be staring down at North America. All the folks who are the PIs and deputy PIs are at the Smithsonian Astrophysical Observatory. Ball Aerospace is the instrument development. We have a lot of project management going on. I'm the deputy program applications lead. We have a lot of institutions involved here. This initially started way back in the 2014, 2015 time era. And then since then, we've had a lot of additional involvement from numerous air quality agencies, health agencies, other groups across the TEMPO field of regard with involvement with this TEMPO Early Adopters Program, which I'll just touch on briefly in a couple slides later here. So we have also international collaboration within the TEMPO field of regard over North America, but also with other air quality relevant or related air quality geostationary missions that are also either just in orbit or going to be in orbit. I'll touch on those too in one slide. Oh, and our launch date is January 2023. I think the exact date is January 27th, 2023 at this time. So we're getting near launch. Exciting.
Did you mean to stop sharing your slides?
I did not. Let's try to, not sure what happened there. Is it back on?
It is, yes.
All right, sorry about that.
No worries.
Okay, so some kind of basic remote sensing information for those folks who may not understand the basics behind our satellites in space and how they observe. We TEMPO and other instruments that we use quite often for our research and applications are passive remote sensing instruments. So these measure the natural energy or sunlight as reflected or emitted from an observed scene. We have spectral radiometers, and these measure the intensity of radiation in multiple wavelength bands. These are also called multispectral instruments. They're designed for remote sensing of the atmosphere, clouds, aerosols, the ocean, land, etc. What we're going to talk about today and focused on are spectrometers. This is a TEMPO. TEMPO is a spectrometer, a spaceborne spectrometer that will measure this radiation in a large number of narrow spectral bands over a continuous range. And this will be typically referred to as hyperspectral remote sensing imaging. And these are designed for remote sensing of trace gases in space. So, these passive instruments, one key note is that they measure the total amount of pollutants from the surface to the location of the satellite. So it's a column measurement, not a ground-based measurement. That's important to realize as we walk through this information. All right, here's a nice animation I like showing what we're kind of getting from our low Earth orbiting satellites, which have this daily global coverage. So this is an animation showing kind of your typical flight, your typical orbit around Earth once per day. This is an example of our NASA ozone monitoring instrument. which is currently in space, has been in space now for almost 2 decades, in fact. And these are great. They give us global coverage. The major limitation here is they only provide once per day overpasses around the midday time period. So we're not observing that morning to evening or the diurnal evolution of pollutants in the atmosphere from these current satellites. The low Earth orbiting satellites, like I mentioned, provide global coverage every 1 or 2 days. Our current spectrometers are spaceborne spectrometers. So these are the TEMPO-like instruments in space, are OMI and our European Space Agency TROP-OMI satellite instrument. And these spectrometers are really the only current instruments in space that can provide both trace gas and aerosol observations. And of course, that major limitation is that they are in low Earth orbit, so only provide this once per day overpass around the midday time period. Of course, we have coverage from our surface monitor sites as well for monitoring air pollutants, but their coverage is pretty sparse, especially when you think of the global coverage. And this satellite data can really help fill these large gaps in our ground-based monitor coverage that we have, and TEMPO will kind of go above and beyond what we currently have in space, which we'll talk on more. All right, so here's kind of how TEMPO will make its observations across North America. So essentially, like I mentioned, geostationary orbit, where we scans hourly daylight, tropospheric nitrogen dioxide of how TEMPO would make those observations across. So as coverage, this is an approximation of the coverage of TEMPO. I'll show a little more detail to kind of show you how TEMPO will stare down at North America and make those hourly morning to evening scans across this highly populated area of the globe where air pollution can be a concern. All right, so the key thing about TEMPO, it will for sure revolutionize how we conduct air pollution monitoring. There's a wide diversity of emission sources around the globe and over North America that provide or that emit your nitrogen dioxide, sulfur dioxide, carbon monoxide, formaldehyde, particulate matter. And these can come from a diversity of natural and anthropogenic sources. Major anthropogenic sources in the U.S. include vehicles, so our NO2, CO, formaldehyde, and PM emissions from vehicles. And we have the industrial sector and power generation that can provide also emit SO2 emissions along with the others above there. It was kind of a neat natural experiment that we had recently with the COVID-19 lockdown, and we have some kind of really unique results from current satellites in space that show this drastic decrease in air pollutants from the decrease in the human activity during the COVID-19 lockdowns. I'll show one slide on that as an example of what we can get from satellite data from space. And also the chemical processes in the atmosphere lead to this production of secondary pollutants like ozone, which is critical for this crowd here on the call. So, ozone is not it is a secondary pollutant that's formed from precursor emissions in the atmosphere. So ozone is also can be highly evolving and variable throughout the day. And TEMPO will go above and beyond in terms of monitoring ozone in the atmosphere as well, in addition to these other precursor emissions that I noted here on this slide. I kind of wanted to highlight one study that we did during the COVID-19 lockdown because it has relevancy for TEMPO and what TEMPO will monitor. And what we did was we looked at this time period from March to April 2019, and then looked at March to April 2020. So here what we're showing at the top here is the pre-COVID era of using our NASA OMI instrument right here on the left, and our newer launched TROP-OMI instrument. This is a European Space Agency satellite that was launched in 2017, which has much higher spatial resolution detail on air pollutants compared to OMI. So we saw here, and we compared that to March to April 2020. This is the time period of the COVID-19 lockdowns across California. And what we found was, we'd expect was a reduction, a significant reduction in the tropospheric NO2 observed by both OMI and TROP-OMI, especially across the large, LA basin areas. We saw that, similar trend in NO2 reduction from OMI and TROP-OMI. TROP-OMI went above and beyond in terms of also showing decreases in NO2 pollution over smaller or moderate sized cities, like Fresno, California, for example. We saw pretty significant reductions in tropospheric nitrogen dioxide over Fresno that were not apparent through our coarser resolution ozone monitoring instrument. And I like showing this because, TROP-OMI is giving us an idea of the kind of spatial resolution details from space that will be also available from TEMPO after launch. Of course, TEMPO will go above and beyond in providing that information from morning to evening. We get our one daily overpass snapshot from TROP-OMI. So altogether, this improved resolution and instrument sensitivity of TROP-OMI, which is also relevant for TEMPO, can better characterize NO2 pollution and other pollution sources associated with fine scale emissions from smaller scale cities compared to what we had in the past. Okay, so what will TEMPO ultimately provide? Here's the baseline product list requirements from TEMPO, and we have, very relevant for this community here, is our Ozone Profile product. So this will provide, on this table right here, you can see the ozone information that TEMPO will provide in the troposphere. We have a tropospheric ozone column product, and also a planetary boundary layer, or 0 to 2 kilometer ozone product, as we call it. And this will really help monitor ozone pollution where people live and breathe. So this will go above and beyond and also be very relevant in terms of the ozone garden information and community we have here. And also, in addition to that, we have our precursor gases of tropospheric NO2, tropospheric formaldehyde, SO2, and also an aerosol optical depth product. So altogether, this suite of products will enable a new understanding of the emissions and complex chemistry that governs our air quality. And this revolutionary 0 to 2 kilometer ozone product will be really relevant for this ozone garden monitoring activity as well. So a little bit on the data distribution part of this. So with our current launch date set for January 2023, this will, if we hit that launch date as we expect, we plan to have our commissioning phase between mid-May to mid-August 2023. Nominal operations will begin about 6 months after that launch date. And the plan here is to have these level 2, level 3 products, which I just showed in that table here. So this includes the ozone products and NO2, formaldehyde, SO2. The plan is to have those available to the community 6 months after the commissioning phase. So we're shooting for February 2024 timeframe now to have that data to the community, free of charge and publicly available through our NASA Atmospheric Science Data Center, the ASDC. not maybe so relevant for this community here, is that we will have near real-time products, or we plan to have near real-time products. So these mean that at the time will be available shortly after the actual satellite observation time. So this is a latency of 2 to 3 hours. We'll have our standard products as well, which will have a fairly low latency as well, around 6 hours, and our ozone profile is expected to be about a 1 day latency of product to the community. And we have a lot of tools being developed during the pre-launch phase of the mission. This, we're working on, we already have some pre-launch proxy tempo data available to the community in our NASA Earth data portal. We're building other systems, tools, Jupyter notebooks for the community pre-launch, so the community can understand how to process, download, and visualize tempo data as well. All right, so one quick slide here on our Tempo Early Adopters program. Just really helped expand the community involvement to new agencies and what we call our community of potential and community of practice. We're really focused on broadening and enhancing the tempo data and the applications of tempo data, preparing users for the operational tempo data after launch, with the goal of really maximizing and accelerating the value of tempo data for societal benefit. So, we're a very inclusive program, welcome participation from all interested community members. Just if you have an interest or need for using tempo data, that's essentially the baseline requirements for becoming an early adopter. So this program has been ongoing since about formally introduced in the 2018 time period. And we've had a good 3 or 4 years of very active community engagement through workshops, through hosting meetings, through attending meetings, and a bunch of other activities as well. So one part of this early adopters program is looking at building these tempo pre-launch proxy data sets for the community, having that data available like it will be after launch through the NASA Earth data portal, and kind of understanding the data products, the different data variables that are in the files, the download methods, developing tools for the early adopters community. This has all been part of our efforts here, and this really will help enable immediate and effective use of the operational tempo data after launch. I'm showing here is an example, a demonstration of our Tropospheric NO2 vertical column density product, our pre-launch product. This is a day where we actually had a pretty substantial wildfire smoke event out over California region. You can definitely see this is showing hourly data from the morning to evening over this 3-day time period during this wildfire smoke event. And you can really see the high pulses of NO2 and the evolving NO2 patterns due to that wildfire smoke plume that was occurring over this 3-day time period. In addition to other information, you're evolving NO2 pollution over your the LA basin area, for example, the urban emissions that occur there, and also the transportation sector. You see these nice evolving trends in NO2 across the Central Valley of California, right along the major roadway stretch here in that area as well. And we have our total formaldehyde product as well, just highlighting that. And we can get large concentrations of formaldehyde in wildfire smoke plumes as well. So this is showing that hourly formaldehyde product, pre-launch product, and the strong variation in formaldehyde as that wildfire smoke plume evolves throughout the day. And this is just showing a zoom-in shot over the LA basin area. You can see the high level of spatial detail in pollution that we'll get from tempo. So we're not only getting that really incredible detail on the diurnal daytime evolution, but also this really high spatial resolution detail that I kind of highlight through the use of tropomi data in my earlier slide too. All right, so one more product that's, I think, pretty relevant for this community here that I want to quickly show off and demonstrate is our Proxy pre-launch ozone profile data. So this is showing on the left that planetary boundary layer 0 to 2 kilometer ozone product that I mentioned earlier that will be available from Tempo after launch, and the tropospheric ozone product. So, we're getting that boundary layer near surface ozone pollution information on this animation to the left. And you're really able now to, once Tempo data will be available after launch, you're really able to now understand and characterize the amount of ozone pollution that is impacting people nearby the surface level here. Previous satellite missions only provided this information on our tropospheric column ozone or our total column ozone information, which it was incredibly difficult to get much information on the surface level pollution using those kind of products. But Tempo will go above and beyond in providing this planetary boundary layer ozone information. And this is a nice example here, kind of showing how our pre-launch product was able to actually depict these are characterize these areas of higher AQI or air quality index values along the East Coast here. So there are some unhealthy ozone AQI values along the East Coast, and you're able to kind of see the enhancement in ozone pollution in the boundary layer through our pre-launch product as we go throughout the day here along the East Coast. So pretty cool information that Tempo provides. All right, and this is kind of one of my last slides here, just to kind of highlight the fact that we have Tempo, we will have Tempo over North America, and this is slightly out of date. The launch date's actually January 2023. So, but here's kind of where we have Tempo over North America. We currently do have a European or an Asian-led or Korean-led mission over Asia called the Geostationary Environmental Monitoring Spectrometer, providing coverage over this region. It was launched in February 2020, actually. So they are currently providing observations over that region, Tempo-like observations over that domain coverage area. And then we will have Sentinel-4, a European-led mission. I think their launch date is still on track for 2024. So we'll have similar Tempo-like observations over Europe as well. So overall, we have this, kind of really nice coverage over highly populated areas that have these air pollution issues with our geostationary air quality constellation here. Very cool. So lastly, I just wanted to show kind of using our pre-launch Proxy data. It's moving slowly, I think, on my end. Here it goes. Okay, so kind of how Tempo will make its scans from east to west over the field of regard I'm showing here. There's some interruptions in here. It's not animating as smoothly as it should, but what you will see is a full coverage of this over North America for this hourly scan of Tempo from the east to the west here. So kind of see the full coverage that Tempo will provide over these key areas across North America. Yeah, I think there's a little bandwidth issue here, but it's trying. All right, and finally, I just wanted to highlight, we have our Tempo early adopters community mailing list that we interact with folks on and give them information on upcoming events and activities. So if folks are interested in really digging more into details here, we do have that link there where you can sign up for our early adopters community. We have other resources available too. We did publish an air waste management magazine article on Tempo, and also a BAM's Tempo workshop summary is available of a previous workshop we held back in the late 2020 timeframe. So yeah, so this is really cool. We have, you can feel free to give me an email too. My email is down there at the bottom left. And yeah, I will end there.
There we go. All right. Well, thank you, Aaron. That was fantastic. Do folks have questions for Aaron? I'm sure folks have questions. And you are still sharing your screen, you know.
Yeah, I tend to do that. We have this kind of neat little ArcGIS portal that we built for tempo data. So I kind of just plotted up a tropospheric NO2 pre-launch proxy file here. And we can kind of play around in ArcGIS if folks know of ArcGIS. It's kind of a pretty popular tool now in the community. But yeah, feel free to I'll take questions or comments or as a hand up from someone.
Hey, Aaron, this is Joe Wilkins. Thanks for your presentation. I was going to ask, you mentioned ArcGIS work. So I'm in the car. I don't know if you can really hear me well, but ArcGIS work. So we're working on community vulnerability indexes. This is part of the EPA effort, working with Howard University as well as UCLA. And I was wondering if tempo data, early adopter data, could be used to kind of help develop that type of work. Currently, we're using a bunch of ground-based measurement stations, so that would really help supplement.
Yeah, definitely.
So, I was wondering if you could.
Yeah, you're hard to hear.
Sorry, I'll type it into the chat if it helps.
I think I got most of it. But yeah, definitely, we are working on building an ArcGIS framework for tempo. We have the capability to overlay and use our Proxy pre-launch tempo data. I'm showing an example here, if you can see my screen, of a tropospheric NO2 tempo proxy file in our ArcGIS framework. And so we're able to visualize it, query the data, do some analysis on the data. And the cool part about it also is that we are working on building a REST API service, which can serve up GeoTIFF files of tempo data that can be provided to the community as well. So that's kind of one of our major motivations right now as well.
Okay, that's great. Yeah, I'll send you an email and I'll clarify my questions there so you can hear me better.
Okay, sure.
Thank you, though.
Donica, did you have a question for Aaron?
Yeah, Aaron, it's nice to meet you, and thank you for giving this presentation to our Ozone Garden Network. I'm curious how much the tempo team anticipates evaluating based on, EPA monitors and other stations, and how those data will be available, and if there's any thought on updating or correcting algorithms that are used to derive the 0 to 2 meter product based on some of the.
Yeah, it's definitely going to be a major activity. I didn't share that particular slide, but I did make a presentation pretty recently at the Air Waste Management meeting. I'll just share that slide because it is kind of relevant in terms of tempo validation, retrieval algorithm development over the different versions that will be released. We'll have our initial tempo version 1 release, hopefully in that February of 2024 timeframe. But of course, as we know, with all these satellite missions, as we get more validation data, do our validation analysis, we have new versions of products that will be released after that too. One major thing we have ongoing now in the community is we are working on this synergistic tempo air quality science mission campaign. So this is also one of the NASA folks, Laura Judd, is a PI of this mission, and we interacted with her quite a bit on it. So we are focused on these different areas of the tempo field of regard, making our ground-based measurements, also our tempo spectrometer will fly our tempo spectrometer on a aircraft too, to make aircraft measurements over these areas. So that will provide information on our NO2, our ozone measurements in order to validate tempo data. We'll have what we call our TollNet observations as well. You may know of TollNet. TollNet, we have about 6 or 8, I think 6 stations, site locations across North America, and TollNet provides really detailed information on ozone profiles at these point locations. So we can do really detailed tempo validation on our ozone profile products using TollNet data as well. We also have our Pandora spectrometers as well. So these are highlighted here. We have a big deployment of NASA Pandora spectrometers right now in preparation for tempo and in preparation for these field campaigns after launch. So this is kind of showing our current network of Pandora sites across the tempo field of regard. So we're building this out. These will make observations of ozone, NO2, formaldehyde. There's an SO2 product on the table too. So this is another way we will eventually validate our tempo ozone products. So we have Pandora, we'll have aircraft instruments, we'll have TollNet observations. I think all this will really make for, detailed validation and improvements to versions down the road.
Thanks. It's really interesting. I'm just looking at the plot that's in the bottom right of the STAQS primary and secondary sampling domains. And I live in Colorado's Front Range, and I noticed that that's the only one that has those high values at 13 to 15, or I guess for NO2, but has those high values that is not actually selected.
that was interesting. And, I think there's still we can work with Laura Judd on this too, but these are the current outlines of our primary cities. This is, that is, I think that definitely is an area of interest that should be covered, especially with the we know the air pollution issues there and the complex chemistry, and it's a lot of issues that happen in that Front Range region, which would be very valuable to do some validation on. But
yeah, it would be. It's also one of the only regions in the country that is increasing in ozone concentration, and so I feel like I don't know. I don't know who's making those decisions or if they're already finalized and made, but it would be really, I think it would be really useful and beneficial to add that area if it's a possibility, given, like I said, it's the only deep red dot that's not circled and considered right now. So
that's a very good point, and I've heard that before from people, and that definitely should be considered. I agree. It's kind of unfortunate it's not currently highlighted in even a secondary sampling domain, but I think we'll see. Maybe there's plans that are on the table that I don't know of that are looking at the Colorado Front Range. We'll see as time moves forward.
Well, I'll just keep mentioning it, and hopefully it'll make its way up to whoever's making that decision. Definitely
keep on working on it. I do know one good thing is that we do have an active TollNet site. So I'm showing the TollNet, data here, and we have one that is usually always active right along that Colorado Front Range. So for providing good validation for our ozone profile, at least we have a TollNet site in that location for that activity.
Great. Aaron, we have a question in the chat from Susanna asking about how different communities are planning to use tempo data. So kind of who's participating in these early adopters, and what kind of work are you seeing people being interested in doing?
That's a great question. We interact with so many different type of folks. Some are kind of more on the academia side, which are either using, trying to characterize future applications of tempo using our current low Earth orbiting data from Tropospheric, for example, that are kind of highlighting some, what we can expect from tempo after launch. Some folks are even get their hands on the GEMS data that I mentioned before. So it's not publicly available, but there is some private data of GEMS that is being provided to the community. I'm showing some here, in fact. So, we have some GEMS data that folks are using in preparation for Tempo as well. This is a lot on the academia science side. We have, in terms of kind of the air quality agencies and health partners, they're more focused, I think, on using some of our pre-launch proxy data products to start to kind of build tools, build their applications, their needs for Tempo data. We've had these conversations with those folks already, trying to understand kind of their data latency requirements, their needs for various download methods, file formats. So a lot of the air quality agencies and stuff are really just trying to understand how they can ingest this future Tempo data into their operations by using our pre-launch proxy data. So that's been a major motivation on their end. There's so many different kind of applications folks are attempting at this time, in terms of even kind of thinking about using the pre-launch proxy data in conjunction with ground-based monitoring to start thinking about these level 4 surface layer products that we could potentially get from Tempo after launch. We have Tempo will provide this column observation information, but there's different tools, machine learning methods that are being adopted by the community in order to understand how we can take these column observations from satellites to get reliable pollutant information at the surface level using machine learning, using ground-based information, using kind of the network, all this information that we can get out of the different observations to get that information to the community. So I think that's probably a good subset or bandwidth of what people are doing right now in terms of Tempo.
And what about kind of after launch? I know there's a lot of kind of those applications that you have listed on the website. What are some of the things that you're envisioning or folks have mentioned wanting to be able to do with Tempo data, some of the maybe community impact kind of stuff?
Yeah, I think, wildfire smoke is always a major thing, right? So, thinking about how we can utilize the Tempo scanning time and the what we call our special operations of Tempo. I didn't even touch on that. We have a whole nother component of Tempo in terms of special operations where we can really start to get down to even finer, higher temporal resolution, let's say over areas of active wildfire smoke. So we'll be able to monitor those, really evolving smoke patterns, for example, and the NO2 pollution and the ozone pollution that can develop from those wildfire smoke activities. It's a huge engagement there in terms of that. I think the health community, I kind of mentioned their involvement. A lot of these folks are kind of more on what we call our community of potential. So maybe they don't understand satellite data fully at this time, but they want to know how to use that data to better characterize pollution at the ground level. So that's been a major drive for that community, is to start to build these machine learning type concepts, these algorithm method type concepts to better characterize pollution at the surface level and do like epidemiology studies on how ozone pollution or NO2 pollution is impacting human health. So there's been a lot of work there in that community. And and I think, again, a lot of these efforts are just really, truly understanding how folks can build their systems, current systems, to ingest Tempo data right away after launch. So that's always been an issue in the past with satellite data, is that we release this data to the community and folks don't have any kind of tools or information to start to build this into their operational system. So that's a major drive of our early adopters programs, to help these agencies ingest this information into their systems once available after launch. So not 2 years, 3 years after the data is available, but once that data is available after launch is a key motivation.
And then another thing, I see actually a slide about it, and Donica and I both just chatted. We just got the email came through. I see environmental justice workshop you've got going on with.
Oh yeah, I should have mentioned that too. Yeah, we just we can pop that in the chat if you want to. And we just literally announced that today. And folks
Yeah, in
may
like the
not be
last
familiar.
5 minutes.
Yeah, yeah. My colleague, I have a colleague who works on the multi-angle imager for aerosols mission, which is another NASA mission that will make really detailed observations of particulate pollution in the atmosphere. So we're working together with the Maya mission for this environmental justice workshop that we plan to host in early August. So yeah, you can feel free to pop that in the chat, and folks can definitely join if they're interested in that workshop. I think Erica might be paused there.
No, I was just putting in the chat.
Okay.
I was reading and concentrated there for a second. Yeah, I think that'll be of major interest for some of our sites. And
I'm not keeping track of the chat, so if there's anything that people have asked, let me know. Yeah, I will say, you know, if there's no questions, I can always just show off what we have. Am I still sharing my screen?
You are. Now I see myself twice. And
I am.
One thing I think might be interesting, Aaron, is a little bit of some of the green paper potentials or the Earth data, how to access the data. I think both are of interest to our group.
Yeah, definitely. I can walk through this very quickly. Maybe I'll just touch on the Earth data. Now, I will make a note that to get this data currently, you have to be signed up for the early adopters community. So just note that. But I am obviously signed up on that community mailing list, so I'm able to retrieve this data, this tempo pre-launch data that is available on Earth Data here. I'm on the main page here of NASA Earth Data, and it's pretty easy to get to the data and find data. It's a pretty, I think, a very user-friendly portal here. So we're on this main page, just find data, link or button there, and you will have to, for me, I can go to Earth Data Search, which is one of the data access tools that are on that list there, and it'll bring you right to the Earth Data Search page, where this is where you can browse tempo data and download files that are available. You will need to log in. So I'm not yet logged in today, so I'll go ahead and do that. And once you are signed up on our mailing list, and you can actually put in your login credentials, and that email will be associated with your account. Oh, look at that. I guess I logged in just a little bit ago, so I didn't have to put my credentials in. But so I'm logged in now, and you can easily go to the search for collections or topics box here and just type in tempo, and the project tempo will pop up after that. And then you can see these 3 matching collection data products that are available on this page. So for fun, we can just click on our tempo NO2 tropospheric column product. And once you do that, we can also go over to the North America, US area, and now we can kind of actually see the granule level information here as we move across these different. So I mentioned how tempo will have this hourly scan of data. We're seeing this full hourly scan here, but we'll actually distribute data in this granule-like information. So you can see these 10 different granules that are across the tempo field of regard that make up this hourly scan. So you can download, if you're interested in one location, for example, just keep in mind that this is an approximation to the tempo field of regard. We will actually cover Puerto Rico down here. So this is actually shifted a little bit to the west it should be covering Puerto Rico. We don't have that update quite yet in Earth data, but we will get there. But the main point here is if you're interested, let's say in where I'm from, Alabama, we can zoom into Alabama and just download one granule file over that region. So it's kind of cool to do that. You can even go over here and do a filter and look at, let's say you want G04 as granule 4 instead to look over Alabama. And if you do that, you can see all these different granules that will pop up that are just over my area of interest right here. It can really help reduce the data download and the number of files that you're interested in. For example, if we go back and thinking about the ozone gardens, right? Let's look over maybe the Boston area. I believe there's an ozone garden right there, correct? So we can kind of zoom in here and think about Boston area. And we have our granule right here. So we can just download that one granule if you're interested in that, and download those files to really reduce that data download and the data requirements that are needed rather than downloading the full field of our garden. There we go. So we can download these files. There's still a lot of them over this long period of data we have available, but it will definitely be useful for reducing your data intake here. So we can download all those files, and it's pretty easy to do this. And I won't actually download the files on the fly here because, but you can kind of see all the files that I did request are being shown here. And there's 2,000 across this 6-month time period. We have data available from morning to evening. They even have a download script here, which is really nice to use and can make downloading a large number of files much more convenient and easy. So yeah, this is kind of where you can go to download the pre-launch files and do some proxy data development, tool development, develop whatever kind of scripts you might want to take in that data. So that is about all I'll show due to time for our Earth Data Portal. We do have previous workshops that are available that do some demonstrations of that data. If you go to our early adopters page, we have our events page here, and you can go to our Tempo data tutorials from 2021, for example, and we did another one in 2022 where we kind of highlighted that pre-launch proxy data. And the workshop recordings are all available here. You can download those and kind of walk through how we download the data, processed it. We even have a Google Collaboratory notebook that was developed in coordination with Baron Henderson at the EPA here that is available to the community for visualizing and analyzing proxy data. So it's very cool. You can go there and watch the recordings if you have that desire. Yeah, in terms of the green papers, we do have, like was mentioned earlier, made a presentation on this not long ago that can be put up here for reference. Let me try to find that really quickly. Maybe right here. Okay. I think I did highlight what we call the special experiments of Tempo. So here is one slide highlight of that Tempo special observing time. This kind of goes back to our green paper that we're developing in the pre-launch phase of the mission here. So the neat part about Tempo is that up to 25% of our observing time is devoted to these special operations. So we even have sub-hourly frequency information of less than or equal to 10 minutes perhaps over a subset of Tempo steps. So we'll have kind of a smaller granule of information there where we can provide the special operations with reduced east-west spatial coverage. And again, these some key applications here can be air quality disasters. I mentioned the wildfire smoke aspect earlier. We can implement these special operations for dust storms, for example. Tempo provide really great observations of dust. There's always, we had an industrial, industrial accident not long ago where Tempo would have provided really great, valuable information for that industrial explosion. That could be another nice experiment and application for Tempo data. And there's also research studies that we're looking at and using this Tempo special observation time for lightning knocks, soil knocks, and we can actually potentially initiate these special operations a few hours prior to the event, which will be really exceptional for using these for our wildfire smoke events.
Hey, I have a question.
Yeah.
This is Joe, if you can hear me.
I can.
So related to the wildfire event, so I'm particularly interested in that. I was wondering how much lead time will researchers or community users have in terms of knowing which wildfires and seasons y'all will, I guess, point the sensor at? Or will it be agreed upon by a group or a committee? How is that going to work exactly?
Yeah, so we do have a committee which involves me and Kelly Chance and a couple of other people who are going to be part of that committee to kind of, point where Tempo needs a point for these special operations. So, we have ideas on how to, of course, we can think about once we see the wildfire, let's say we have an early detection of a hotspot from, let's say, our GOES ABI, we can quickly potentially transition that and use Tempo special observations and point to that area of interest. And like I said, if we are able to get down to the point of having those operations being implemented a few hours prior to the event, that'd be great. That will make things a little more difficult. These preload scan patterns can easily be initiated a few days prior to the event. Obviously, that would be a kind of a complication when it comes to some of these wildfire smoke events that can really create problems quickly. But we're kind of working on these things right now, trying to understand how best we can implement these and with as little prior time as needed to actually point that instrument where it needs to be. Can I kind of answer your question?
I've kind of got a follow-up to Joe's question. So what about some of these non-fire, like wildfires, if somebody wanted to do a research study over a city, how are those getting selected, right? Because those can happen further in advance than a wildfire, but if somebody wanted to do a study over Washington, D.C., how would they ask to be part of that?
So are you more looking at the prescribed burns, or what are, you said the wildfire?
He said wildfires. I'm just asking kind of in general, like if somebody had a research study how are folks getting these research studies on the within the special observing time?
Yeah. So if it's pretty easy to do that, we have a request form for folks to fill out and to submit to me, and if they are interested in conducting or looking at a research study over some area of the field of regard that would benefit from these Tempo special operations. So that is, I can share the link to that form. It's on our website, actually, where folks can access that and request special observation time.
Yeah, that would be helpful, because if we can predict pretty much when there's going to be an outbreak, or if we have a sense of when it will be one, that might be good. Okay. Thank you.
kind of a major driver right now, is trying to understand, in what locations across the field of regard are of interest for these operations of tempo, and how can we work with the community to best implement these after launch, to not also impact the standard hourly scan patterns of tempo too, right? We don't want to impact potentially other end users, stakeholders. We gotta be careful in that regard too, when thinking about how best to conduct these scans.
While you find that, Donica, I'll point out one of the special experiments here. The second one here is thinking about Colorado's front range. So
yeah, so we do have and I will just share that there's a request form that is on our site that folks can download, and if they wish to submit one of these special operations to the community.
Great. Well, I'm realizing it is now 2 o'clock, so I want to respect people's time. But thank you so much for being here with us, Aaron. This is fantastic. We've shared a number of links from you and website that you've shared in the chat, and we'll be sure to get those to folks so that anybody wants to follow up on some of these things that you've shared, they have access.
Yeah, thank you. I appreciate it. It was
Yeah,
fun
thanks,
being here.
Aaron. It was a great talk.
Yeah,
we really appreciate you.
Yeah, thanks everyone. I also just wanted to highlight that our next meeting is tentatively scheduled for August 15th, which is a Monday at 1 o'clock for this. 1 o'clock Eastern, sorry.